In this problem, we're given a defined benefit plan that provides retirement benefit of $500 per month for each year of service at the normal retirement age of 65. The only decrement before retirement is death. We can use the standard ultimate life table. Deaths are uniformly distributed, so we have UDD. On retirement before age 65, there's a benefit adjusted such that the reduced benefit taken immediately. Okay, so this means that if you take early retirement, there's a reduced benefit. Okay, and its actual present value is the same as the accrued benefit deferred to age 65. And we want to compare this age 64. So if we take early retirement at age 64, that's going to be equivalent to age 65. So we're given a 5% interest, and the annuity due is 13.086. So the first thing we're going to do is look at early retirement. So we're going to say age 64 retirement. Okay, so given by this over here. So there is $500 per month for each year of service. So 12 months in a year. We're going to say, actually, we're not given how many years of service. So we're just going to call it N. And we're using number of years of service since up to age 64. And we want to multiply that by the annuity due at age 64. And then we're going to multiply it by some reduction factor. Okay, so that's by bullet point 4. So we're going to call it 1 minus R. And R is the amount we're going to be reducing it by. And this has to be actuarially equivalent to the present value, actually equivalent to the accrued benefit deferred to age 65. So we're going to be taking the age 65 and discounting back to age 64. So, but first, let's look at the premium. There's $500 being paid of premium for 12 months. And there's N years of service. So we're looking at it age 64. So up until age 64, we're saying there's N years of service. But the annuity due will be for age 65, and we have to discount it back to age 64. So our goal here is to solve for R. Now both sides of the equation have 512 factors, so those cancel, and they also have factors of N. So we have the annuity multiplied by 1 minus R. Okay, and then we have this on the right side. So we can solve for the annuity due at age 64 by using the UDD. So we know that that's going to be alpha 12 times 8.64 minus beta 12. We're going to use a standard ultimate life table, so we can just plug in the values. And we get that the annuity is 13.373. So we're going to plug that back in to the equation. I still don't know what the reduction factor is because that's what I'm looking for. Now the annuity due at age 65, that's 13.086. V is 1 over 1 plus I, which is 1 over 1.05. And the probability we survive age 64 will be 1 minus 0.005 288. So when we solve for R, we end up getting 0.07 2986, and we want R as a percentage, so that would be 7.3%.